Guys, welcome to Not So Nerdy channel. Today we are solving our 23rd question called combination sum. We are on backtrack topic, so it's a little tricky to understand, but let's keep going. Given an array of distinct integers candidates and a target integer target, return a list of all unique combinations of the candidates where the chosen numbers sum to target. So you have a set of numbers and you need to find those numbers which sum up to add up to that particular target which has been given. Okay, so you can check from this example. You have 2, 3, 6, 7. So your answers are 2, 2, 3 and 7. Why? Because the same number may be chosen from candidates an unlimited number of times. So you can choose unlimited number of times the same number you can repeat to get your result. Two combinations are unique if the frequency of at least, okay, you need to have the unique solutions. Like here, if you have 2, 2, 3, you cannot have 2, 3, 2 or 3, 2, 2 because they are the same thing, right? So this is the question, and you can see from here from the example that in this you have one solution as 2 to 3, the other as 7. So you get two combinations. In the next example you have 2, 3, 5 and your target is 8. So you can have either 4 2s, 2, 3, 3 or 3, 5. So visualizing it in the mind is a little difficult. So I'll just try to explain it here. Okay, so you have your 2, 3, 6 and 7. So in backtracking, we generally use depth first search, and I'm going to cover that topic in my next video. So let's try to understand first that you have two choices initially. Okay, you can have 2, you start from 2, right? So you can have 2 or you can have nothing. Okay, then at 2 you can repeat your numbers, right? So when you're at 2 you can have 2 and 2 which sums up to 4, or you can have just 2, like you do not plan to add anything. Now here again you can have 2, 2, 2 because till now our solution, like we have the sum as less than 7 as our less than our target value, so it's still valid. Or you can choose not to have 2, 2, like not to add the 2. Now here your next sum would be 8. Okay, so this won't be our solution. Okay, this would not result up to 7. Okay, so you move to your next thing, which is 2, 2. Now you're not planning to add 2, so you'll change your index to 3. So here your next possibility would be 2, 2, 3, which adds up to your 7. So you get a one solution as 2, 2, 3. Now here you have not added 2. Instead you jump to 2 and 3. You either jump to 2 and 3 or you keep it as 2. So when you have 2 and 3, your next possibility is either you can add 3 or you can add 6 or 7. Now here when you'll add 3, like your next possibility will be 2, 3 and 3, which would be greater than 7, right? So this possibility will be it won't be possible, so you will backtrack. So every time you are just going to your solution previous solution, you will pop this and you will backtrack. Okay, now here at 2 you are choosing not to include 3, so you go to the next index, which is 6. So you will have 2, 6, or and if you not plan to keep 6, you'll have 2. So 2 and 6 sums up to 8. So again this will not be a solution. Okay, it will not be a solution. This will not be a solution, right? Great. Now here also, now you will check for your next index, which is 7. So you add 2 and 7, which is again not a solution, it's greater than your target value. So you will backtrack. So every time you are backtracking and changing your possibilities. This is a depth first search way. Okay. Now here you're planning not to keep 2, right? So you will keep 3. You'll start with 3, or you will not keep a 3. At 3, your next possible values will be 6 or 7, which will be greater than 7. So I'm not showing it here because of the less space, but it will be like 9 or 10. Okay, so these won't be a possible solution, so we are not going to look into it. Right now here you will have 2 possibilities, because we are skipping 3, we have already checked for it. We will either check for 6 or we will not. Okay, now at 6, you do not, your next possibility will be 7, because you cannot, you have already checked for 2, you have already checked for 3, your next possibility is 6, and again there is no other solution for it, so you will not keep it as your answer. Then you will have 2 possibilities again, which is 7 and a blank. Now 7 is your one solution, right? So it's gonna accept it, and this portion, like where there are empty, and finally when it gives you an empty, you will return. So every time you are popping your results to go back to backtrack your like solutions. So initially you check for 2, 2, 2, 2, 2, 2. If not possible, you'll go back to 2, 2, then you'll check for another solution, right? So I hope this is clear. It's a little messy, but let's try to code it. Okay, so you have your result. Okay, you are going to get a list of your solutions, so you'll have your result. Then you'll have a function, say let's call it backtrack, or yeah, let's keep it backtrack. Okay, now you will have your start index, which is going to iterate right through the whole what we say, the array. So you will have something as start, then you will have your let's change it to something else. Let's not keep it start, let's keep it, okay, I'm going to keep it start. Okay, then you'll have a combination. So you will, your current combination to check, right? So you will have some current combination. Let's not give it a big name, let's keep it current. Okay, and you will have your sum, current sum, because you are checking each time that whether your sum is up till target or not. So you'll have your current sum. Okay, so what will be our base case? Our base case will be when your if current, no, like first let's store our solution. Okay, so if current sum will be equal to our target, you will append that current combination in the result. So you will do result dot append current. Yes, let's change this name to combination, because this will be a better for understanding. Okay, I hope you know this notation, because I have explained it in my previous video. You can go and check that out. Okay, and then you will return your solution. Next thing will be if your current sum is greater than your target value. So if it is greater than the if it is greater than your target value, you will simply return your function. Okay, Now you will iterate through uh, each value in the, like we checked here, we are iterating through each value here, right? We are iterating through each of these. So we'll have for I in range from start, your start is at there, so start till your length of candidates, because that's your given array. So for I in range start till length of candidates, you will simply you will add your value in the current combination, right? So you will have current combination dot append candidates of I. So you are appending the current value in your combination. Next, you will call your function again to check the following things and continue. So you will call backtrack. Now here your I is your start value. Whatever position your I is, that's your start value. Then your current combination will be same combination as you have already updated or appended your value here. Okay. The only thing that will change will be your current sum. It will get updated with the candidate of the with the particular number. So current sum plus candidates of I. So next you will on doing the following steps, lastly you'll have to pop out the elements to get the previous solution to check the other possibilities, right? So you will do combination dot pop, and outside of this you will have your backtrack initialized at 0, an empty list and 0. Your initial current sum is 0, your start value is 0, and it's an empty list. And finally you will return your result. So I hope I'll show the dry run in soon, but let's test this first. Okay. So let's try to understand how this is done, how the solution is, how we are getting our solution. So we have 2, 3, 6 and 7. Okay, so initially we have we are at 0th index, which is 2. Okay, our backtrack function starts with 0 and empty list and the 0 sum. So here these values are not met because our current sum is 0, which is not equal to target, and our sum is not greater than target. So we go to the for loop. Here at for I in range, your start is at 0 and your length is 4. So it will go from 0 to 3, right? So your I value is 0. At 0, your candidate of 0 is 2. So you will add it in your combination. So you will get 2 in your combination, right? Now you will backtrack. So your I will stay as 0. You will have your combination as 2, and you will check for more possibilities. So your current sum will get updated to 2. Again, you'll call this function, and your current sum is not equal to target yet, and it's not greater than target. So your I is still 0. So at 0, it's still 2, and you append that in your combination. So your combination becomes 2, 2. And now again you are calling the backtrack function, and with the new combination, which is 2, 2. So your I is still 0, your combination has been updated, and your current sum has become 4. and again it's not meeting these criterias, so you append another 2 here, so you get 2 2 2, and then your sum gets updated to 6 and it's still not reached, but now your sum gets appended again with a 2 and it becomes 8. Now 8 is not a solution, like it's greater than target, so you will return. On returning, your this function will get over and you will come to your popping function. So you will pop the last element, you will backtrack to the previous one. Now here again we checked all the possibilities and we are not getting a solution, so we'll pop and we'll get 2 2. Your I will get your I will get updated to 1. It will change, and your combination will append the candidate 1. Now your candidate 1 is 3, so your combination will become 2 comma 2 comma 3. Now with this new combination, you call your backtrack function and your I is now at 1. Your combination is 2 comma 2 comma 3 and your sum is now 7. Now sum is equal to your target, so you will append this combination to your result. Okay, now you will check for the and you will return. So on returning, you will pop the element. Okay, now you will check for the next possible solutions, and then you're uh, you'll keep on like popping. So we are not going to check for 2 3 or 6 because that will like that like if we are going to pop this function, you'll this element, you'll have 2 3, which will be 5, and which is like if you add your next element, it will give more than the um, desired value. So again, there won't be any combination from this, so you'll have to check for all the possibilities by going through the same steps, and finally you'll get your 7 as well, one of the possible solutions. So it's a little tricky to understand, and dry run and explaining this was a little tricky as well for me, and I hope you get the working of it. And yeah, like feel free to ask your doubts to me, and backtrack, like go through the previous videos, and there's like a very similar pattern when it comes to solving backtrack questions. So you can just find some pattern to it and try to visualize these things as well. So yeah, thank you so much.